Hello everyone, this is Fawad. Welcome to Future on Cloud. Welcome back on Python for Network video series. As I promised, just in 1 hour you will be expert in Python for network, particularly Python for network automation. So in our previous three videos, we have learned how you can configure loopback, VLAN, and batch, and how you can configure multiple devices with three options. And in our last video, we have configured how you can take backup of your network devices. This is the last video of this series where we are going to deploy our network topology. And these are the playbooks which we are using, the Python syntax. You are expert now. And this is the topology which we are going to configure. You can expand this topology as much as you like, but you have to follow the same technique, same script, which I'm going to show you in a while. So in this topology, I'm going to configure switch 1 with 10 VLANs and number of configurations. I'll show you in a while. These links will be configured in trunk mode 14 and 15. 15 to 15, 14 to 14. These will be configured in trunk mode. These are, you can say, my out of band management so that I'm able to access these devices. So let me show you the base template, which you have to be configured prior to start the deployment. Base template, like you have to configure the ACL, which will be common for all. Like you have a monitoring server and you have to register these devices to that particular monitoring server. You have to specify the ACL. So uh, the NMS trap should be forwarded to that particular monitoring server, or you have radius server where you have to forward all the logs and the user detail to get it authenticate. And you have a seam server where you have to forward all the logging details. So these kind of stuff, these are the typical configuration which you have to configure on your hundreds of devices. Just configure it one, enable your devices for zero touch provisioning, access it and execute the code. Irrespective how many times your management asks you to change the base template, it's on a fly. You don't need to spend hours and hours to log in on individual device to make changes on your base template, right? So this is the zero touch provisioning. Like first of all, you have to enable your device so that it can communicate with that with your jump server or with your laptop through which you are going to push all that configuration. So let's jump into our environment without wasting time. So this is exactly the same topology, my GNS server, where I'm going to deploy the configuration. So this is my jump server. Let me show you first the current configuration of the devices. So let me zoom in a while. So I just reboot these devices and remove all the extra configuration. It's a pretty brand new devices, you can say, to run. Except the base configuration like the username, password, IP address, nothing is there. As you can see, all interfaces are blank. The default configuration. After we push the configuration, port number 14 and 15 will be configured in trunk mode, and these interface will be part of VLAN 10. These interface will be part of VLAN 5 somehow, and some SNMP and ACL configuration you will see shortly here. And likewise for this switch as well, switch number 2, accept the base configuration to access the device. As you can see here, time zone is not there, IP domain lookup, all that stuff is not available here. But we are going to configure all that stuff with the help of base template, which I have already prepared. Just to save the time, let me show you the configuration of third device. No extra configuration is available here. So likewise for switch number 4, everything is blank. So I am going to push the base configuration. What is our base configuration and how it work? Again, you have to use these available libraries. I am going to open a file which I have prepared with my, not this one. Let me open it. Desktop, Python, and my switch.txt. So this is the file which contain the four IP addresses 38, 39, 138, 139, 140, and 141. Switch 1, switch 2, switch 3, and switch 4. So it will read the file. This line will read the file, and let me one as well because I was using this previous video. Okay, so it read the file, read first IP, prompt for username, password, then it will configure VLANs with the help of for loop. It will configure VLAN from 2 to 10. You have to add +1 of your last point. Like you have to configure VLAN 2 to 10. Then you have to specify 2 to 11. Then it will configure 2 to 10. This is the syntax. We cannot do anything. Anyway, we have to follow the rule. And it will specify the VLAN name along with the along with the VLAN number. Then what we are going to do is we are going to configure time zone, IP domain, no IP domain lookup, no IP source route, interface range, fast Ethernet 1/0 to 1/5 will be configured in this mode and it will be part of VLAN 5 and it will be no shut and interface range from 6 to 10 will be access switch and it will be part of VLAN 10. Then again, it will be configured as a no shut and interface range port number 14 and 15 will be configured with .1q encapsulation and it will be configured as a trunk port. As I mentioned, port number 14 and 15 will be configured as a trunk port. Then IP routing should be enabled. We are going to configure OSPF protocol and just for sake of testing, I'm going to advertise all the networks in area 0. Then I'm going to configure an access list. Access list name is future on cloud, and this is for the monitoring purpose. These are my monitoring server IPs so that this device can communicate with my monitoring servers. And then I am going to configure logging as well. So this is my logging server IP. Then I will configure an NTP server as well. This is the NTP server IP address. So all these devices will get the time from this NTP server. SNMP community, I'm going to define for the read-only SNMP server IP address to send the trap. I'm going to use SNMP version 2. Code guard is enabled for all of the devices. So this is the base template. You can modify it based on your requirement, whatever the typical configuration you have, just edit it, copy the complete code, edit based on your requirement, specify the IP address in this text file, specify the path where you are going to store it, then you are good to go. It's that simple. So let me execute this command and we will see all that configuration should be. So let's play it. Asking for the username, then the password. Read the file 138. It is pushing the configuration. Let me open the terminal here. It successfully delivered the configuration on switch 1. It has opened up switch 2. Switch 2 is done with all the configuration. Everything is perfect. But here is one suggestion. First of all, you need to test it with one device, execute the commands, copy the same text from the actual switch, prepare your base template, follow the sequence. Wherever you need to specify the exit, wherever you need to specify the no shut, wherever you specified the end, then again you need to come back in the configuration mode. Like here I have specified router OSPF 1, then you have to specify the network ID. If you did not specify exit here and jump over to the next one, it will not work. It will give you an error. So you have to follow the proper sequence. It is recommended to test it with one device, then prepare your base template, then execute it for rest of the device to avoid any issue. So as you can see here, it is executed on all four switches. Configuration is complete. Let me go through and verify the configuration. So here you can see our protocol is in loading to full state. Our routing protocol is propagated. So this is the proof how you can protocols and all that stuff with the help of Python. How powerful language and how simple it is for network. So let me show you the running configuration first. Whatever we have configured here. So here you can see 1 to 5 port of VLAN 5 from 6 to 10. These ports are part of VLAN 10, 11, 12, 13 are not in use. Port number 14 and 15 are configured in trunk mode. OSPF we have configured, and so far we have advertised all the networks, and the ACL we have configured, logging we have configured SNMP, and we have configured NTP as well. Uh, This is we have verified on switch number 4. Let's see here. Let's verify the routing P out. Show running. So all that configuration is available here. So why it is not showing the routes? Because there is a single network, only 192.168.159 dot. If there are multiple networks, it will execute everything. So just for sake of testing, we just loop back one IP address one and which two. Three. Four. Okay, let me verify IP. So here you can see I am getting routes through the OSPF because we have pushed OSPF configuration through the Ansible and advertise all the networks. So we are getting this config. Right. So this is how simple it is. The Python for network. All the playbook is available in my GitHub library. I will share this deployment code in the description of this video. So try it, test it, and make your life easy. So that's it from my side. This is it for now. Stay tuned, keep watching. See you in upcoming